Hi everyone, what we want to do today is help you prepare for your midterm. And so these are going to be different problems to help you for your midterm. And so what you should do after you read the question for each problem, stop the video, work through the problem yourself, and then play on and see how I work through the problem and see how I explain how you should work through it. And so for number 1, true or false? If the correlation coefficient is negative, then the slope of the linear regression model must also be negative. And so this is definitely true. The correlation coefficient and the slope, they always are going to have the same sign. And so if the correlation coefficient is negative, then the slope is going to be negative. If your slope is positive, the correlation coefficient is going to be positive. They will always have the same sign, and so this is true. Number 2, calculate the residual for the 0.17 when the equation of your least square regression model is y equals 4 minus 2x. And so remember to find your residual. Your residual is going to be equal to what you actually observed, your y, minus what you predicted, your y hat. And so here's our line, y equals 4 minus 2x. What you want to do, and that is a 2, you want to plug in 1 into x and find what is your predicted y. And so you're going to have 4 minus 2 times 1 equal to 4 minus 2. And so 4 minus 2 is 2. And so what you're going to do, there is your y hat. You're going to plug that in. Your observed y is from the point, the 1, 7. And so 7 is y. And so you're going to have 7 minus 2. And so your residual is going to be 5. Let's say a researcher asks a group of students to provide what their party is. And so you're either Democrat, Republican, Independent, Moderate, or you're none. And so what type of graph do you think is going to be most appropriate to display this type of data? Well, first you should be thinking, what type of data do we have? And so here you're either Democrat, or you're Republican, or you're independent, or you're moderate, or you're none. And so you're looking at different categories, and so this is definitely categorical data. And so then you should think about what type of graphs did we learn to display categorical data, where you can use a bar chart, or you can use a pie chart. Either one will be appropriate to display this type of data. Number 4, so here we have the SAT. The scores have a normal distribution. It has a mean of 1026 and a standard deviation of 209. What is the probability that Emily's SAT score is going to be more than 1318? And so you want to recall what is the formula to find a z-score. And so here we're definitely looking at the population. And so we're going to have x minus the population mean divided by the population standard deviation. And so when you find this probability, what you're looking at, and you can make yourself a sketch, and so pretend that's somewhat of a normal curve. Here's our mean at 1026. Emily, we're looking at a score for 1318. And we want to see what is the probability for that to be more than 1318. And so what you're going to do is find the z-score first. You're going to have Emily's score as your x, 1318, minus the mean, 1026, divided by the standard deviation, 209. And so if you work that out, you should get 1.397. And so if you round, 1.40. And so what you can do is you want to find the probability, and so you want to take your calculator out and to find that probability. And so remember, when you're finding the probability, what you're going to go to is that normal CDF. And so you're going to go to second VARS. You're going to go down to normal CDF, click enter. The first thing you're going to do is think of your lower limit. Here we want to see for the probability that Emily's score is more than 1318. And so our lower limit is going to be Emily's score, 1318, comma, and so we want to see if it's more than, and so you're going to do second, and then the comma button to get your E, and so you're going to have E99, comma, the mean for the SAT, 1026, comma, then the standard deviation, 209, and then close that parenthesis. And so there's your probability, 0.081. And so roughly the probability for Emily to have a score more than 1318 is about 8.1%. And so here we want to know what measure of center, the mean or the median, will be appropriate for describing household incomes for families in a very large city. And so if you think about this, you're looking at different incomes for families, and so some might have very little, some might have very high, and so the median would be the best measure of center, because no matter how far apart these incomes are, the median will not change. It won't be affected if someone has a very high income, but the mean would be affected. It will want to chase after that high income, or if there was a very low income, it will want to chase after that. And so the median will stay the same. It will not be affected. And so the median will be the appropriate measure of center for household incomes. And so here we have salaries for a small corporation. 5 employees make $25,000, 8 make $18,000, 4 make $20,000, and 1 makes $1,500 per year. And so you want to find the mean, median, standard deviation, and IQR. And so you want your calculator out. And you want to start typing in these numbers. And so you're going to want to watch how you type these numbers in. You have 5 people that make $25,000. And so you're going to type in 25,000 5 times. Then you're going to type in 18,000 8 times, 20,000 4 times, and 150,000 1 time. And so while you're doing that, I'll bring my calculator up. And so here's my list for all these values. And so once you have those typed in, you want to go to Stat, go to Calculate. You want to go to the 1 variable stats. Here I had them in L1. So I click Enter. And so here's our mean X bar. And so that's 27,722. Here's our standard deviation, that's X. If you go down, here's our median, MED. And so to find the IQR, you're going to need Q3 and Q1. And so why don't you pause the video and write down all these values that you have on your calculator. And so what we found was X bar was equal to 27,722. Here SX is equal to 30,663. our median is equal to 20,000. And then we want to find our IQR. And so Q3 was 25,000 minus Q1, 18,000. And so if you find that difference, you should get 7,000 for your IQR. Number 7. And so again, you're going to want your calculator out. And so here we have the SAT score and GPA at graduation. And so again, you can predict a student's GPA based off their SAT score. So it's been said. And so here we want to predict GPA from SAT. And so what you're going to do is you want to make two lists inside your calculator. And so you should write these numbers down or have them inside your calculator. And so while you're doing that, I'll pour mine up. And so here's my SAT in L2. Here's my GPA in L3. And so once you have these values in, what you're going to do is find your regression line. You want to go to Stat, go over to Test, and you want to go down to Lin Regression T-Test, click Enter. And so for me, I had SAT in L2, I had my GPA in L3, the frequency is going to be 1, we don't care about this line, here's Y1, and so hit Calculate. And we don't care, for the most part, what's going up at top. Here's our intercept A at 1.87. Our slope B is at 0.000887. Our correlation of determination, R squared, is at 0.0454, and so roughly 4.5%. And our correlation coefficient is at 0.213. And so I will pause the video and write down everything I have found on this calculator. And so for the first part we have A, we want to find and interpret R squared. And so when we look at R squared, we said it came out to be as 4.5%. Remember, R squared is always going to be in form of a percent. And so this is going to tell us that 4.5% of the variance in Y, the GPA, is explained by small changes in our X, the SAT. And so remember, R squared is always going to be the percent of the variance, the error that was taken into account in our model from our Y, and it's explained by any small changes that happen in our X. And so next, we want to find and interpret the slope. And so we found that the slope B, it was 0.000887. And so let's just write the regression line. Sometimes it might be easier to interpret this if you see it in the regression line. You don't have to, but I'm going to do that. And so GPA was our Y, equal to our intercept 1.87, plus our slope 0.000887, and our X is SAT. And so what is this slope trying to tell us here in context of the problem? And so what this is trying to say is that when X, or SAT, increases by 1 unit, our predicted y value, our GPA, it's also going to increase by the amount of the slope. .000887. And so each time a student's SAT score increases by 1, your predicted GPA is going to increase by .000887. That's what the slope is trying to tell you. And so lastly, we want to predict the GPA for a graduating senior with an SAT of 800. And so you can do this in different ways. You can use the calculator, you can make the scatter plot and find it, or you can use the model, the regression line, and find your GPA that way. And so I'm going to just use the model. For some reason, this is the method I like. I don't know. Everyone has their own way of doing things. And so what we're going to do is you're going to plug in 800 for SAT. You're going to times your SAT, the 800, by your slope, and then add it to your GPA. And so if you do that, you should get 2.58. If you do this with the scatter plot on your calculator, you should get the exact same answer. And so this is just the way I prefer to do it. There are other ways. And so lastly, we want to construct, well not lastly, this is just number 8. What we want to do is we want to make a histogram and a box plot for the sample data here. And when you make this, you want to talk about the shape, and then if there are any outliers, you want to note how many and what are their values. And so again, pause the video, you're going to need your calculator out, and you want to make a list with these values in there. And so, if we look at mine, I have those values in L4, and they keep going down. And so, what we want to do is we want to make a histogram and a box plot. Let's work with the histogram first. And so, you want to go second, stat plot. You want to click enter. And so, you want to find the right icon for histogram, which is this one. Click enter. And then you want to tell it what list you had those in. I had mine in L4. Then you go hit zoom and hit 9 for zoom stat. Just ignore that line right there. That's coming from the regression. Just ignore it. And so what does this shape look like to you for this histogram? And so what you should be saying that it looks like, if you see a tail, is going to the right. And so this is skewed right here. And so do you notice anything else about this histogram? And the answer should be yes. Here's a nice gap right in between. And so here, this is most likely going to be an outlier. And so that's how you want to describe the histogram. Now let's do this for a box plot. Go to second, stat plot again. Click enter. And so you want to find the icon for your box plot. And so that's going to be this icon right here. Click enter. And then if you have the right X list already in, hit zoom and hit 9. Again, just ignore that line that's coming from the regression. And so here's our box plot. And here you can tell we have an outlier. And so let's just go up to it and see what that value is. It looks like we only have one true outlier. And so if you keep moving, that's about going to be the one that we have for the 30,000. And so here, the 3,000 is definitely the outlier for our problem. It's the only outlier that we have. Number 9. Let's suppose that the heights for male German Shepherd dogs have a normal distribution with a mean of 25 inches and a standard deviation of 2.5 inches. Between what values do the heights of 99.7% of male German Shepherds fall? And so this is going back to the 68, 95, 99.7% more. And so what you're trying to look for, if you draw yourself the normal curve, and so that's a little bit better from last time, we have our mean at 25 inches. We have a standard deviation equal to 2.5 inches. Here we're looking at 99.7%. Remember that 99.7% is 3 standard deviations from the mean. And so what we're going to have when we look at 99.7% is you're going to have your mean plus and minus 3 times the standard deviation. And so you want to find 2 values to find that range. And so what you're going to have is the mean of 25 plus and minus 3 times 2.5. And so what you're going to have is 25 minus 3 times 2.5. And then you're going to have 25 plus 3 times 2.5. And so why don't you pause and do that right now? And so if you found those numbers, you should get 32.5 when you add, and you should have got 17.5 when you subtract. And so right there, there's our 99.7%. And so what this is saying right here is that for all male German Shepherd dogs, 99.7% of them is going to have a height between 17.5 and 32.5 inches. And so you definitely want to make sure you look at that 68, 95, 99% more again. If you're looking at 68, instead of that 3 there, what you will have is a 1, 95, it would have been a 2. And so you just want to make sure you go over that 4 again. And then our last problem, let's say there's a small accounting firm that pays its 5 clerks $35,000, the 2 junior accountants $80,000, and the firm owner is going to get $320,000. And so let's suppose that the firm gives no raises to the clerks and junior accountant, while the owner is going to take an increase to $450,000. That seems fair, doesn't it? And so you want to see how does this change affect the median. And so let's just look at this. You could do this on your calculator, but let's just write this out. Here you have 5 clerks that's making $35,000. And so let's just write 35,000 5 times. Then what you have are 2 junior accountants making $80,000. And then you have the owner making the $32,000 here. Not $32,000, $320,000. If you found the median, it's going to be somewhere between these 2 numbers here, these 2 $35,000s. It's somewhere between right in here. There's your median right there. And so you want to see, if this is our median, what will happen if you changed the owners? The owner is going to take an increase. Is that going to change the median at all? Well, here this is going to go up to 450,000. Does that affect anything in the middle there? No, it doesn't. The median is not affected, and so that owner could get as high as a raise, and the median is not going to change. Now, if you change one of the clerks, then you could say the median will be affected. But here, if you just change the owners, it's not going to be affected. The mean would have been affected, but the median is unaffected by this change here. And so these are good problems to review for your midterm. And so just go back and work through these problems. Go back to the videos. Go back to the ones that have summary problems. And just work through all those problems. And you will be ready for your midterm.